terms of Kubernetes we talk about. That is something in deep dive we can have the interest as well, and we can talk about it a lot. But basically, if I talk about today's session agenda, would be more focusing about the how the managed services multiple cloud platforms are providing, and specifically we'll be targeting for the EKS, which is being provided by AWS Cloud Platform. Great, great. Avinash? Hi, Avinash. Are you there? Okay, moving forward. Prabha? Okay, Prakash?
Yeah, hi everyone. Currently, I'm working at SCL in IC operations team. So actually, I'm very new to EKS. I only know basic things about EKS. So I want to know more about this domain and this work.
Okay, great.
Thank you.
Thanks for joining, Prakash. Pramod? Pramod? Are you there?
Deepak, I think Pramod just joined, so he may not have context that
Okay.
he has
So,
to.
Pramod, what we are doing is, till the time people are joining, what we can do is we can introduce ourselves and what are expectations do you have regarding the session today? So that's what all we are discussing.
Can I know? Hi. Hello.
Hello.
Yeah. Hi. Can I know what's the outcome we can get, like in this session at the end of the session? Like whether it's a basic on EKS or any cluster deployments or something, or just
Okay.
one or.
Okay. Abdul, basically, as whenever we start with the topic, we introduce about the topic, right? And direct jumping into or hopping into the main cluster setup deployments or playing with the application deployment onto a cluster would be discussed as a separate session as well. But over here we'll be discussing about the introduction to EKS, how all cluster. We will be seeing the cluster deployment with the AWS console and different components as well. We will be also talking about the
What's
cluster
the
components and the control component, the work and load components as well, how they integrate with each other, how they communicate. That's all will be what all we will be discussing about in today's session.
Okay, thank you.
Okay, I think Pramod isn't responding back, so we can move.
Hi, Deepak. Actually,
Yeah,
I was
Pramod,
wearing my headsets.
no issues.
Actually, I don't have any idea in the EKS. I only done my work on AKS. I'm an Azure engineer. So, what is the mini section about this one?
Okay, great. So definitely, by the forthcoming when we start the session, we will be getting to know that what all points will be going to discuss in today's session and the total agenda of today's workshop, today's webinar.
Okay, thank you. Thank you.
Sure. Uh, Raja. Okay. Sandeep.
Okay, good morning, Deepak. Good morning, everyone. So, my expectation from this session would be having some clarity in terms of, let's say, if you go with a managed service, or let's say if you do a self setup of Kubernetes, how different is it? What advantage you get from it?
Mhm.
And then nitty gritties behind Kubernetes challenges and what are the typical challenges and how you solve them. The best practices in terms of setting up EKS. That's what I would be expecting.
Okay. Great. Thanks for tuning in. Shiva.
Hey, hi. Thanks for giving me an opportunity to, review kind of my expectations. Yeah, I thought this would be a session about high-level introduction to EKS, expecting that we already worked on EKS, and maybe a small assignment or application which we will be deploying on EKS. Yeah.
Okay. Okay. Great.
ठीक है अच्छा ओके
Okay.
ठीक है मैं भेजती हूँ आपको
Moving forward, we have. I might be wrong with the pronunciation. Sorry for that. So we have Mulavia. Mulovia. Is it right? I think we have more people joining in. So I think Chiranjeevi, you are left for the introduction part.
Yeah, Deepak.
Yeah.
I,
So Chiranjeevi, basically what we are discussing is that you can introduce yourself and what all expectations do you have regarding the session.
actually, I'm also new to the EKS and deployment actually. So I want to learn these things actually from the basics. I'm expecting to be like after the whole session might be it will be help to little bit idea on that EKS and mediator like that.
Okay. Great. Great. Probably we have.
Maybe
Yeah,
we should time box this introduction so that we can start the session on
for sure.
time.
Just further 2 minutes more and we'll start with the main session. Okay, Bagiri.
Yeah, hi Deepak.
Yeah, hi.
Actually, even I'm expecting, even I'm new to this EKS of process and everything. So just I want to learn everything, the new how it will be the now deployment process and everything.
Okay, great, great. So yeah, pretty good. If I talk about the whole discussion, what we had just with all you people. So basically, some people are new to the Kubernetes word, or some people are new to EKS as well. So basically, what all you people wanted is that we should cover the basics, that how what all offloading or what all burden operational tasks which has been removed by the managed services which has been provided by today's cloud platforms. So we'll be discussing about that, and specifically we'll be talking about EKS, how EKS is helping us out in removing all that operational task burdens which we used to do when we initially set up a Kubernetes cluster. So that's all we will be talking about in today's session. So before starting, I'll ask Tarun that are we live with the session now?
Yes, Deepak, we are.
Yeah, yeah.
Great, great. So I'll start with my introduction first. So hello everyone, myself Deepak Gupta. So I have been, being a DevOps enthusiast, I have been into this field for a couple of years. And if I talk about my day-to-day work life, I have been cognitive about designing scalable, highly available, and fault-tolerant systems onto different cloud platforms. Apart from this, what I believe is, as being a learner, I try to tend that I should deliver back to the community as well. So we try to do open source contribution from our side, be it about Docker images, Helm charts, or Terraform modules as well. And what I also love from my side, as today we are gathered over here to deliver some public workshops, knowledge sharing sessions as well. So yeah, that's a quick intro about myself. We have Tanya as well from our team. She'll be helping us out, and happy to help you out people in delivering today's session, today's workshop, be it about with the training purpose or the lab side as well. So what I'll be discussing about. I'll ask Tanya to introduce herself. Over to you, Tanya.
Thank you so much, Deepak. Hi everyone, my name is Tanya and I am from OpsTree Solutions since 1 year, and I am also a DevOps enthusiast. Also, along with day-to-day activities, I like taking sessions. So today I'll be your co-host, and also it will be great if you could ask questions on the chat. It will be my pleasure to answer you all, and please keep this session as interactive as possible. So thank you so much. Over to you, Deepak.
Okay, thanks, Anya. As said by Tanya as well, so we'll as we gathered the information from you all, what all expectations do you have? So I do have some expectation from you people as well. So as we know that it's basically a webinar session which we are delivering today. So in the starting from the starting, 80% delivered, and if you people are having any queries, any of the if you are not getting any point, what you can do is you can directly hop into the chat box of the Google Meet, and we'll from our side, our team would be helping you out and answering your queries. Or if at some point you think that I didn't get this topic, you can directly put it into the chat, or Tanya would be instigating me that we can repeat that topic again, right? So I hope this is clear to everyone. Start with the session.
Yeah.
Okay. So, so introduction to EKS. What all we will be discussing about is the EKS, and moving forward, we'll discuss about the today's agenda. That what all components, what all topics we'll be covering in today's session. So, starting from the Kubernetes core components, that what all. Just to give a quick glance over the core component, because as we just discussed that some people are new to Kubernetes word as well. So we'll be giving a quick overview, but we expect from your people's side is that you have a basic idea of Kubernetes. Moving forward, we'll be discussing about orchestration fundamentals. When we are aware of orchestration fundamentals, the tool which we generally use in today's time, that is Kubernetes, we'll be seeing that what are different ways does today's era provide us to set up Kubernetes onto our different platforms. Then moving forward, we have the main topic which we have gathered over here. That would be your EKS. After that, EKS introduction. Further following with the EKS architecture and core components. Also, we'll be discussing that how we deploy EKS cluster onto our cloud platforms, and how do we integrate with it, and how we can use it. After that, we'll be working on it and the basic networking concepts, that how our cluster planes, our control planes, and the worker node planes integrate with each other, how they communicate. And in last, we'll be discussing some of the best practices for EKS as well. So starting from the scratch part, as we all know that in today's time, we people are moving up, or we can say they are in the transition phase from a monolithic architecture to the microservices part, right? And when we talk about microservices, so we say that by breaking large applications down into a small, independently functioning services. So microservices, what microservice does is microservices enables advances in agility and flexibility for us, for be it about the developers, be it about DevOps engineers or the operations engineer as well. So what microservices means is microservices means a loosely coupled or a decoupled. So basically those all the application components which can be developed, deployed, and scaled at individual level. So that is all about microservices. So the concepts comes that when we got the microservices, got a step ahead from monolith. But what we see is going forward, the number of microservices are also increasing day by day, right? And when this comes, then with containerization into the place, and because containerization helps microservices which can be quickly deployed on a demand as part of our continuous delivery process. I hope that makes sense, right? So talking about a quick gesture on the containerization part, we can say that we can discuss from a basic idea which we used to follow in the past experiences, right? We have a Node.js basic application which needed to be deployed onto our production servers, or be it any environment of the servers. So if we talk about the past way, what we use, the virtualization way, and then how we transfer to the containerization way, right? So basically, when we talk about the VMwares, we have our hardware associated with our main system, then we have our operating system and a hypervisor over it. And when we talk about hypervisor, what hypervisor helps us out is to set up or spin up multiple VMs onto our main system, right? And once we have spin up the multiple VMs onto our system, we can deploy that Node.js up our application, be it about Node.js, Java-based, Python-based, any of the one. But what we see in the virtualization concept was that the main hardware resources were maximum utilized, right? And when we talk about that, we do when I need to deploy any other of the application onto the same server, that wasn't possible for me because all my resources has been blocked over here, right? That's what was the process where we move from VMs to the from virtualization to the containerization way, in which we have the OS based level sharing. And when we talk about the resource level, uh, it's tend to in the format comes like um, the resources when are used by the containers, they are used by the containers, and when the application purpose has been completed and the containers has done its work, then the main resources which has been utilized from the main server would be returning back to the main resource of the servers, right? But whenever we mention containers, what most people thinks is tend to default understanding brings us about Docker or Kubernetes these days. But container technology has actively been around for a quite some time, right? If I talk about past back experiences, then back in 2008, when Linux kernels introduced the C groups, or knowingly named as control groups, basically which paved the container technologies. It could be your Docker in today's time, or your Rocket or other container runtime engine as well. So over here we can see that when we talk about containers, we have our host system, the hardware, the host-based system, and we have set up the container runtime engine over here. Or for here, we have considered Docker as a container runtime engine, and we'll be spinning up our applications. So basically, when we talk about containerization, so basically it follows a three minimal process ways, right? So what we have is we have our application packed up with all the system binaries and the libraries which needed for the application, which are written in the form of Docker file, a basic manifest which we talk about. And from a Docker file, what we do is we spin up or we build our image, right? We build a Docker image. And finally, after that, what we do is with the help of our Docker image, we can spin up our containers as well, right? So which are over here. Why did we move over here as well? Because in this concept, what we used to see is that the developers might be building their application on their systems, and it was working fine. But when they deployed onto the main production servers or the any of the environment server, then we saw that there was some dependency broken. There were issues, and across issues was raising, right? But when we moved to the containerization way, all these issues were resolved because they were basically the application which were built on to the developer side. They just created a, you can say they just created a system file snapshot, right? They created a file snapshot which consists of all the application dependencies, libraries, requirements which is needed to run onto a system, basically system over here. And when we spin up a container, so basically host level sharing is being done from the host OS, which is the core concept of the containerization, and the resources are being utilized from the main resources. And once the resources are utilized or the work of the container has been done, then these resources go back to your main system. So that is basic overall which we discuss about the containerization way. Moving forward, we have the Kubernetes core components, right? So basically the agenda was not to talk about the main Kubernetes core components or singly drawing them, but what we will do is we'll do a quick cool exercise over here, which would be giving a gist of all the basic of the Kubernetes, but talking in terms of the perspective of creating a pod, right? So let's take that. Uh, when we talk about Kubernetes, we all are aware that we have one of our master node, that is our control plane, we can say, and then we have our worker nodes as well, right? On which our heavy lifting work is going on, means your deployment of your application or your pods are running. Basically, your containers are running onto these machines, your compute resources, right? So let's take an example that Tanya said that I want to run an application onto my worker nodes, right, or onto my Kubernetes cluster. And Tanya awarded the command that kubectl apply, right? So basically, when Tanya said that I have a workload which needed to be deployed onto my Kubernetes cluster, she just gave the command, and then what all happens behind the scenes while dealing with the Kubernetes cluster, we'll be discussing that. So basically, the main component, right, when we talk about the master nodes, is your Kubernetes API server, right? So basically, whenever the main component, or we can say from where the client interaction happens, or from where the node interaction happens, is your Kube API server, right? So if I say Tanya wrote the command to kubectl apply, what it'll do is it directly hop this command to the Kube API server. What API server does is first API server authenticates and authorize. So authentication and authorization is something which can be discussed as well. Basically, if I give you a simple gist of authentication and authorization, right? So we can say that we are working in an organization, right? And you all people have an identity card, right? Your identity card to access to your organization premises, right? So at the first gate, at the starting gate of your organization, that is something where the gatekeeper or the security guard stands up and asks you to show the identity, that are you authenticated to enter this premises, right? So basically that's your authentication, that you have the ID, you have that token that you can enter into that premise. So that is something authentication. Then in the organization we talk about, we have multiple towers, right? We have different tower for different work, different towers for different work, or we can say organizations in premises as well inside a single tower, right? Then you are authorized to a specific tower or a specific cube box in which you are authorized to work on. So that is something authorization process. That is authentication and authorization. So similarly over here as well, when Tanya awarded a command of kubectl apply, API server will check, authenticate and authorize that is Tanya is eligible to access my Kubernetes cluster and set up the workloads onto my servers. Then yeah, API server awarded that yeah, Tanya is allowed. What then API server does is, does API server schedule the workload onto my worker nodes? So no. What startingly it does is it's gives that desired state value to the HCD database. That is basically your second component, the second main component of your master nodes. That is your key value data store parameters, in which all the values are stored, all the cluster state information, be it about the status of the worker nodes, the pods, all it is stored in the HCD in the form of key value store, right? After that, once that command has been registered, or API server has given the desired state and the desired state has been stored in the HCD cluster, what it does, it gives back the response to the API server that I have registered that workload which Tanya has given to me. And after that, once the API server got the response back from HCD, it gives back it to Tanya and say your workload has been deployed onto a cluster. But till now, does we see that any of the workload has been set up onto our worker nodes? So no. In terms of Kubernetes concern, over here we are done, right? Tanya will be getting the response back that my workload is being set up. But now what is all components which comes into the picture and helps to set up the workload onto my worker nodes? Starting with the first one comes as the scheduler, the third main component, right? So basically what scheduler does is, constantly pinging your API servers, defaultly or basically roughly we can say at an interval of 5 seconds, that scheduler keeps on asking API servers that hey, do we have any of the workload which we need to set up onto our worker nodes? So API server says no, as of now I don't have anything. Again, after 5 seconds it again pings back to the API server and asks for any of the workload. And yeah, now API server says that yes, Tanya is asking to set up a workload onto our cluster, and now you have to check that which worker node. So basically the work of the scheduler is to constantly ping the API servers and also to check that which worker node would be suitable to set up the workloads onto the cluster, right? So once scheduler get to know that Tanya do have the workload, so it will stop over here and ask that. Then what we do is we will take a pause over here and we'll see that what all components does worker nodes have. So three components we have onto our worker node sides. If I talk about the main component, that would be your kubelet, which we have. Right. So basically, kubelet is a component which is directly communicating with the API servers, right? Which are giving regular health checks on a periodic basis, which are saying that is your worker node healthy or not. Whenever we have the workloads, then API server would be pinging back to the kubelet and setting up the workloads. So that's what kubelet is all about. And then the second part, the main part, is your container runtime engine, right? Which is being set up by the container runtime interface, right? So over here in this case, we can say Docker has been set up for a container runtime engine. And thirdly, we can say we have a kubeproxy. Basically, kubeproxy doesn't help to set up our workloads, but in generic, we say that kubeproxy is something which helps to communicate with internode, right? When we have the workload which needed to be deployed or distributed across or span your cluster, across your worker nodes. So kubeproxy helps in that, and that's all the components which we have on our worker node sites, right? Okay, so now coming back, that when we said that we need to deploy our workloads onto my worker node components, so we the scheduler get to know that Tanya has a workload which needed to be set up. What scheduler will do is scheduler will check out all the out factors might be set up by cluster administrator, right? Or will check with the kubelet, right? Will check with the kubelets that which worker node would be suitable for setting up the workload which Tanya has asked to me to do so, right? Keeping out, checking out all the factors, be it about resources, the hardware resources available in the worker node would be suitable or not. Every factor will be keeping in mind. A scheduler will check that and select a node on which the workload can be deployed, right? And let's say that scheduler choose the second worker node to deploy that workload. So once the scheduler has select that worker node, does workload has been deployed? So in that case as well, no. What scheduler does is scheduler again send back that response to the API server and says that I have found the worker node on which the workload can be loaded and on which the pods can be set up. So again, once the scheduler has sent that response to the API server, is it now that my workload would be set up on my worker nodes? Again, then it's a no. What API server would do is again it will throw that response to the HCD cluster, which will create an actual state or actual success writing of the actual condition which is needed to be deployed onto my worker nodes. And what it do is it's check that HCDs check that is the actual state is matching the desired state which was awarded by Tanya. So its check has not been done yet, and again response back to the API server. And now API server as sent by the scheduler that second worker node is the most suitable one to set up the load. So then API servers goes to the kubelet of the second worker node, and my pod is set up on my second worker node. That's how a workload or the basic components altogether works in Kubernetes. And at last, if we talk about, then if in some case my pod is deleted or terminated, right? Somehow something bad happened. Then what happens in that case? Then we have another main component, that is your controller manager, right? In this case, we have multiple controller manager, be it about node, replication controller manager, ingress controllers, many more controllers we do have. So in this specific case, we have the replication controller, which would be again in the directly communicating with the API servers. And when it sees that the pod which needed to be set up but has got terminated, then again it would be his work to ping back to the API server and schedule up the new pod as per the requirement. So it could be the worker, again the same process goes back, which node would be suitable to set up the workloads. I hope till this point of time people are clear with the objective of the containerization and a basic of the Kubernetes, that what all we discussed. I hope, yes. Okay. Moving forward. So what we have is now orchestration fundamentals, right? As we are now aware about the Kubernetes, Kubernetes as a tool which is helping. Basically, Kubernetes. What is Kubernetes? Kubernetes is just an open source tool which helps out to manage or to deploy or to scale the containerized applications onto any of our platform, right? Okay, just give me a minute. Sorry. So as we said that Kubernetes is an open source tool which helps to manage and scales the containerized applications. So what are orchestration fundamentals does it provide, right? And what all we need from our side? Let's discuss about that as well. So let's say that I have a basic microservice application which have three components. Like we can say we have a front end. In that application tier we have a backend, right, and a database as well, right? So these are the three microservices component which have onto my for my application. If I talk about in developer's perspective to set up the application, what it would be focusing mainly on would be these three, that these three applications should be running fine, right? But if we talk in terms of the ops engineer or the DevOps practices which are need to be followed in today's time, we need to check about the deployments, the scalability, the highly availability concept, right? So as per said that we are talking about Kubernetes. So what all Kubernetes orchestration fundamentals points are being shared by us, we'll be discussing about that. So let's say that I have a master component, master node. If we talk about in production level grade, we don't have a single master, right? We at least set up a three node master plane in which we have the HCD, we have the API servers, right? And let's say then we have three worker nodes. Right, over here I have my three worker nodes. So once the ops engineer or the DevOps guy get to know that I need to deploy this application onto a production level cluster of Kubernetes, what it does is the first point for the orchestration fundamentals comes is that we need to deploy our application, right? So let's say all the components has been deployed onto my first worker node, right? Let's say my my front end, my back end, and my DB has deployed onto it, right? Then what we said is that we are not limited just over here. We want to check, we want to follow all the best practices which is being followed. So when we talk about orchestration fundamental, first when we are done with the deployment, we have the scalability, right? So let's say what I'm doing is, or the engineer is doing from his side is scaling the application. And over here, what it does is it has scaled the application to three of the worker nodes. Right now, my application is perfectly running with the high availability concepts as well, right? If some went wrong for my first of the worker node, then my two worker nodes would be serving the traffic, right? The third part comes as networking part, right? When we say that we have the microservices onto our systems, then what we say is the communication between all these components should be working fine. And how does we can manage that in any of the orchestration tool or the specific tool which we are talking about today, Kubernetes, right? So Kubernetes provides us the network concepts, the networking concepts, right? What it does is it gives us the single endpoint so that my application communicate at the single point level rather jumping or hopping directly into a single application for each of the every front end application. So basically what it does is it's create a service, right? We have the service for it. We create a backend service and then service as an endpoint, and then front end application would be communicating with that service endpoint. And behind the scenes, all my three pods IPs would be inside or under those target points, right? Similar goes for the database as well. We do create a service for that as well, and similar goes process. The similar process has been followed for this as well. I hope this makes sense. So, thirdly, the orchestration part was with networking, which we said. We are done with the deployment, we are done with the scaling concept, we are done with the networking concept. The final orchestration fundamental which comes is the insights, right? Once we have deployed our application onto a platform, we need to monitor it as well, right? So be it about if my nodes are failing, if my pods are failing, if they are running fine or not, if they are giving the healthy checks or not. So insights also matters to us, right? In that case, if my pods goes down something, so we have, as we already discussed in this part, in the below part, that we do have the controller managers onto our system, which helps us out to check out the regular health checks for my pods, for my nodes, each and everything. And even when we talk about Kubernetes, so Kubernetes is basically a very high pluginable approach open source project, right? So what you can do is you can integrate many of the open source project presented in today's CNCF community, be it about Prometheus or Istio, and which helps us out to integrate well with our cluster platform, and gives us out the logging and the scaling capability, the logging and the monitoring capabilities as well. So these are the four basic or the main, we can say, main followed orchestration fundamental points which needed to be followed in today's time, or when dealing with any of your microservice application deployment onto our Kubernetes cluster. I hope makes sense. Moving further, so we discussed till now what we discuss is that we discuss about the microservices, we discuss about the Kubernetes components, right? We even discuss about the orchestration fundamental with taking an example of a 3-tier application which we are deploying onto our platform. We discuss about the deployment, scaling, networking, and insights as well. So when we talk about Kubernetes, we can see that in the Kubernetes core components, we have multiple components. We have the API servers, we have the etcd, we have kubelet, kubeproxy, right? We have to set up a container runtime, and master controller just not ends over here. It goes much more beyond that. So while dealing with Kubernetes setup, we have multiple tools in today's time, which helps us out to do so, right? First of all, when we are in the phase of testing purpose, right, we are setting up a cluster in which we just need to test our applications, or we want to set up the whole deployment process, that how would it work, how networking would work. So what people generally do is people generally set up a mini cube, which helps us out to set up a single cluster with a single worker node onto their systems. Then we have a KubeADM, whole Kubernetes way, which helps us out to set up each and every different component of master nodes onto your systems. So KubeADM is one of the way. Then we have open source Terraform modules as well, which helps us out to set up the clusters, the Kubernetes cluster onto your platforms. We can set up with the help of Ansible, combining with Terraform to set up Kubernetes cluster as well. And then we see multiple cloud platforms which are providing today's Kubernetes managed services, and that we'll be talking all about, right? That why we are on today's managed Kubernetes service instead of going on your own. So when we just said that we have the maximum components, the operational task, when we talk about setting up a Kubernetes cluster, then what we have to do is we have to look out for each and everything, right? We have to look out for the high availability of our Kubernetes master plane, right? We need to set up the etcds, the basic. If I talk about basically, you might be setting a highly availability concept. So all those operational tasks, what you have to do is you have to look out on your own. So what it does is that it increases an operational burden on the DevOps engineer or the organization teams as well. So right, so then in that case, all these platforms in today's time are helping you out. We can talk about EKS, which is being provided by AWS. We can talk about AKS, which is being provided by Azure, or we can talk about GKE as well, which is being provided by Google Cloud Platforms. So what all they are doing, what all benefits they are giving. So basically, so into and the main topic which we are talking about is the EKS part, right? So why EKS, right? Why we are dealing with EKS and why should we switch to EKS part is because EKS runs and scales the Kubernetes control plane. When I talk about control plane, then it means your master node, right? Which have all your HCDs, your APIs, servers, your controller managers, your schedulers, right? So basically what EKS does is EKS runs and scales the Kubernetes control plane across multiple ACs to ensure your high availability. Right. When we talk about other beneficial points which EKS provides us is EKS automatically scales our control plane instances based on the load, detects them and even replaces the unhealthy control plane instances nodes as well because they are integrated in a single region with the multiple AZs concept. Right, so they do all the regular checkups onto your control plane instances that are they performing healthy or not. Then another benefit points which we can say talk about is these are integrated with different AWS services to provide you scalability, your security for your application. It could be the ECR repository, right? When you are dealing with Kubernetes, when you are dealing with containers, you have your own images, right? Own application images which you want to build, right? So what you can do is you can integrate your clusters with the ECR, and that is also one of the AWS managed AWS services in which you host a container repository registry in which you can publish or push your Docker images, right? We have an integration of load balancers, the IAM concept, which helps you out to authenticate and authorize onto your Kubernetes cluster access. So that's all benefit. What EKS provides us instead of doing or having your workload or operational task handling on your own, what you can do is you can just give it to all those operational tasks, all those management of the control planes to the AWS side, and they'll be the people who will be handling all those operational tasks. They'll be running up-to-date versions of Kubernetes so that we can use all the existing plugins and the toolings also from which has been provided from the Kubernetes community in the open source. So this is all benefit what EKS provides. So concluding that with what is EKS? So basically, it is a managed service that you can use to run your Kubernetes without needing to install, operate, and maintain your Kubernetes control plane and hosts. So basically, statements also says that Amazon Elastic Kubernetes service is a managed Kubernetes service that makes it easy for you to run Kubernetes on AWS and on-prems. On-prem, when we said about on-prem, then EKS also provide your EKS Anywhere concept, in which you integrate with your on-prem data centers. You give all the details to the AWS teams, and then they set up your EKS onto your on-prem data centers as well. And with Amazon EKS, an enterprise can use Kubernetes without having to install, operate, or manage the container orchestration software that we already discussed. Right. I hope till this point of time, no one has the confusion that why we switched from to the containerization way, then to Kubernetes as an orchestration tool, and leaving all those operational tasks, we switched to a service, a managed service, which a cloud platform is providing us and taking all the burden from our side, from the management side, from the high availability side, or from the scaling side for our control planes. I hope makes sense. Yes or no? Okay, in this case, we can say yes or no. So I will be assured that you people are getting it.
Yes, yes.
Yes.
Okay, great, great. So now coming forward, when we have discussed that we are moving towards the EKS and EKS core components, right? So we talk about EKS architecture or components we have. So what we say is basically EKS architecture. Architecture is just the same as the architecture which Kubernetes follows, yeah, right? Because it's been built up on the main Kubernetes core components. So we talk about EKS architectures, and then we have two primary components: your EKS control planes and the EKS nodes or the worker nodes that are registered with control planes, right? So if you talk about EKS control planes, EKS consists of.
Deepak, can you maximize your PPT? It's not readable.
Okay, sure. Thanks. So basically, when we discuss about the EKS control plane, so this is the one of the core functionality which EKS provide as a managed service. So the control plane act as your master node for a Kubernetes architecture. So basically, when we talk about master node is also known as control plane. We already discussed that as well, which is responsible for managing your worker slave nodes efficiently, and they interact with the worker node too. So basically what we meant by interaction is that they schedule the pods, they monitor the worker nodes, start or restart the pods, manage the new worker nodes joining the cluster. So with all the different core components which the master nodes have, when we talk about the start or restart the pods, then we have controller managers, we monitor the worker nodes, then we have the node controller as well. So differently, basically all the core components of the master nodes are working when we talk about the control plane. And as we said that EKS is something which gives you a managed service, managed control plane. So basically the control plane run in an account managed by AWS. And basically what it does is, as we said, that they run a high availability concept when they are dealing with the control plane provided by your managed service of EKS. They run into a three AZs in a single region. So considering, for taking an example of taking AP South 1, the Mumbai region, they have the three AZs and they'll be hosting your master nodes in all those three different AZs, right? So basically the control plane runs in an account that is managed by AWS, and the Kubernetes API is exposed via Amazon EKS endpoint, which is associated with your cluster. And each Amazon EKS cluster control plane is a single tenant and a unique which runs on its own set of Amazon EC2 instances. So when I talk about single tenant, there we drops to the concept of single tenant and multi-tenant. So basically, when we talk about single tenant in terms of the EKS control plane, so EKS runs a single tenant Kubernetes control plane for each cluster. That means in the control plane infra is not shared across cluster or any other AWS account. It would be specific to your account, it would be specific to your cluster, and to run own sets of Amazon EC2 instances which are only just working for you. Right, so that's the basic single tenant concept and control plane. And if we talk about when we deal with the architecture of control plane, right, that what are different components control plane have. So when we talk about the highly availability concept, EKS, what EKS from its side is doing is that, so CP control plane consists of at least 2 API servers instances, 3 HCD instances that run across all the 3 AZs within a region, as we taken the example of AP South 1. And when we talk about all those HCDs, so all that data stored by HCD nodes are associated with the EBS volumes. Basically, when we talk about AWS, then we have the EBS volumes or the EFS. So over here, when we talk about HCD are associated with EBS volumes, which are encrypted. So basically, you are also seeing the security kind of satisfaction as well from the EKS side. So those EBS volumes are encrypted using AWS KMS. And yeah, and when we talk about the control plane is set up in the multiple AZs, then what it is done is it is fronted by an NLB, right? Basically, a network load balancer is fronted by all those 3 nodes, all those 3 control plane nodes, and then what we get is an API endpoint where from you people or the client can connect to your Kubernetes cluster. I hope it makes sense. Right? Yes or no?
Yeah.
Great. As discussed till now, what we have discussed is about the EKS core component, right? The EKS control plane component. The first component has been covered, and that is the main managed component which is being provided or being resolved by EKS, that taking up all the overburden from our side to manage the control plane, to manage those API servers, the HCDs, right? All it would be managed by AWS from their side. So over here we can see that I have a test EKS cluster deployed onto my AWS system and is being on the US East one side. So what we can do is this is the running cluster. We can just check that what all parameters does clusters take to create a new cluster, and what all parameters we do give from our side. Okay, just give me a minute. Sorry for that. I'm not following the best practice. I'm logging it using a root user. Okay. So we have when we are trying to create a cluster, then what all parameters goes while configuring a cluster is you can give a name to your cluster, EKS demo, let's say. Then we say the Kubernetes version, which version of Kubernetes you want to proceed with, right? So latestly, the default one is the latest one, which EKS says from their side. Finally, the third thing and the major thing which EKS or the AWS asks from their side is to provide you a cluster service role to them. And so already I have created an EKS cluster role. If I show you that what all policy basically this. Okay, just give me a minute. Okay, I can just open directly the IAM policy. So basically, the role of that cluster role policy is to give your AWS teams and access to all the permission which Kubernetes needs to do in your all to do from your side. That is basically when we set up a Kubernetes cluster and when we start setting up the heavy lifting onto our worker nodes, we do need the EBS volumes to persist our data, right? We need load balancers to route to basically give a public access to our applications, right? And so that basically our clients can access to our application. We'll be creating load balancers, right? All those different things. So basically what this IAM role consists of is the cluster policy, basically, which gives the permission to Kubernetes to do everything on your behalf, like creating load balancer, EKS, tagging, etc. So basically this what it Amazon EKS cluster policy we give. And when we talk about the services which it's have is the EC2 auto scaling, the load balancers, the IAM, the ELBs, the KMS. When we talk about, when we just said that it have the HCD, right? And HCD is being encrypted with the help of HCD is storing the data in the EBS volumes and encrypting with the help of KMS. So all does it do is from your side, it needs a cluster policy so that AWS team can manage on your behalf to create each and everything, be it your volumes or your load balancers. So this is what we provide from our part. Though we have provided the EKS cluster role policy, then secret encryption. Over here you can choose that if you want to do that, enable envelope encryption of Kubernetes secrets. So basically these are the core components of Kubernetes which you use, the secrets, the secret kind, right? So for that as well, it's asking that do you need a secret encryption as well or not. So right now, as of now, we are going the default one. Then it's asks you the networking part, right? We do need to provide the VPCs and the subnets that will host your Kubernetes resources, your load balancers, your worker nodes, right? And in this case, over here, what we see is a default VPC which we are using, and these all are the public subnets which has been onto this default VPC. So subnets can be public, private, or both. If I talk about a production grade level setup into the organization, we do have a mix of both, right? We do have the private subnets, we do have the public subnets. It's just the basic concept when we deal with the AWS services directly, starting from the scratch infrastructure creation, provisioning, right? So creating from a VPC, then to the subnets, we will be creating some private subnets, then public subnets. NAT gateway would be helping us out to translate from the private subnets, right? And we have the internet gateways connected to our public subnets directly. So what we do in that concept is, what we were doing is we were putting our application onto a private subnet. We were hosting our load balancers right onto our public subnets, and similar goes in Kubernetes as well. So that's what is asked to do, so that you should keep both, the mix of both the public subnets and the private subnets as well. So moving forward, we do provide the just let me do one thing. Okay, so I have provided the subnet details, the VPC details, right? Then we have something related to the cluster endpoint access. So over here we are going with the default one. It states that the public, when we are dealing with the public cluster endpoint, the cluster endpoint is accessible from the outside of your VPC as well, right? Worker node traffic will leave your VPC to connect to the endpoint. And when we talk about public and private, then cluster endpoint is accessible from outside of your VPC and within your VPC as well. And when we talk about private, then your cluster endpoint would be only be accessible through your VPC, not outside that. So when we talk about production grade, then definitely we'll be proceeding with the private. Over here we are just going with the purpose of demo. Then I'm keeping it as a public and endpoint access. Then the main part comes, the networking part, right? The Amazon VPC CNI. We'll be discussing about it as well. The main when we'll be dealing with the networking part, that how our worker nodes are integrating with our control plane, and when we schedule a pod onto any of our worker node, how does VPC CNI plugins helps us, or how the basically the networking of Kubernetes of EKS helps us from the default kube networking which we used to follow when we were setting up Kubernetes onto our or on our own or on our prem services which were managed by ourselves, right? So basically, we'll as of now, what we are doing is we are going with the default one for each and everything with the VPC, CNI, the core DNS, and the kube proxy. And when we talk about the default one, that means your latest versions of these services, right? Then the third part, what comes while dealing with the parameters, is configure logging part. So basically, in this case, what Amazon EKS does is Amazon EKS integrate with your CloudWatch logs, which helps us out to log the API servers, the audit, the authenticator, controller, manager, scheduler. So everything would be logged onto your CloudWatch logs, and you will be having an easy access to that, so that if any of the issues arises, you will be easily able to debug that. So over here, as of now, we are not proceeding with the logging part. And finally, what we see is the review and the create option. So basically, we create a cluster, and after creating a cluster, it takes some time, right, to come into an active state basically. And once your cluster is activated, so you are good to use with it. Okay, I think yeah, so this is the part. Moving forward, what I'll show you, which we have the test EKS. Okay, configuration. Moving part to the configuration part. As now you can see over here, I have an active cluster running on. Basically, this is the EKS cluster being managed by AWS. We don't have to interfere anything in this. Also you can see, we don't see any of the node machines details which are being given to us, right? These are the worker nodes which I haven't integrated with my cluster plane, my control plane. But for now, we don't see any of the idea. We are not getting the idea of how many master nodes has been set up for this cluster, what all behind thing is going on, right? What we finally or directly get from EKS side is that EKS gives us the API server endpoint, which helps us to communicate with it when we used to throw those kubectl commands, right? And even these API endpoints helps when the worker nodes want to talk, and because already we have seen that the communication goes from the both side, from your master node as well, from your control plane as well. So these API endpoint would be the one which would be helping you out directly. So basically over here you would be setting and these would be the API endpoint for your control plane master, API for the control planes, and basically this would be the point where the all the interaction would be going on, redirection will be going on, right? So this is the thing which we are getting. We have the certificate authority as well. So we'll talk about this as well, that how does it helps when we are dealing with the certificate and when we start creating the worker nodes, and how does we integrate our worker nodes, or how do we register our worker nodes with our EKS cluster? How does it helps? So basically these all these things which we are getting up. After this, what we need from our side is that we need to start interacting with our Kubernetes cluster, right? As my Kubernetes cluster has been set up, I need to connect to my, so that I can throw those commands. I can deploy my workloads onto my worker nodes, right? So for that, what you can do is what we do is we have set up an EC2 machine, which would be considered as a Kubernetes admin, I can say. Basically, a machine in which I'll be setting up my AWS CLI, my kubectl resources, the CLI, right? And from that machine, I'll be communicating with my cluster. So that's all what I have. I have a basic machine EC2 instance setup where I have set up my kubectl, my AWS CLI as well. And now what we can do is we can directly jump into my EC2 machine, and to register. When we deal with Kubernetes, what all we have is the kube config file, right? The kube config is the place where all our cluster information has been stored, and which helps to communicate with your cluster as well. So basically, with the basic the AWS CLI command, what you can do is you can update your kube config onto your system base system. What you just throw this basic command onto your runtime terminal, that AWS EKS. You provide the region, in which region you have hosted your cluster. Then you give a update kube config file and the name of the cluster. And what it does is it updates your kube config file, right? So over here you can see that that is the certificate authority data which we see in this part, right? We have the API and server points, right? The server endpoint we have, right? With the cluster ARN we have the cluster ARN. So basically it's just defining all the details of my EKS cluster, from which user it has been created. So basically when we deals with the users, as mentioned, that I created this with a root user, right? This account, this cluster has been created with a root user. That way it is not showing the users concept, the AWS IAM authenticator concept, which lists out that which user created this cluster. But we'll be discussing about that as well when we'll be discussing about the best practices of security. Right, so basically over here you can see is that your kube cluster configuration has been set up onto your kube config file, and now onwards what you can do is you can throw up your commands, and you can start seeing the services which has been deployed or set up with your Kubernetes cluster. Over here I have some deployments, that's why it's showing over here, but basically my cluster is being set up, right? And if I talk about the default resources which we get, so we can see in the kube system. So basically, when you see, so these are your AWS VPC CNI plugins, which helps to set up the networking between your nodes. All these are the default components which comes with the EKS part. The core DNS, which tends to be the name resolver, the kube proxies, which would be set up onto your worker nodes, right? So basically till this point of time you might be clear that how do we set up the Amazon EKS cluster, right, which is being managed by AWS. Any issues in that?
No, Deepak.
Just got to think the one response. What about others? Are they getting?
Yeah.
Okay, great. So, mm, moving forward, when we are set up with our Kubernetes control plane, right? What we need from our side is we need to set up the worker nodes, right? The worker nodes so that we can start our heavy lifting work. We can deploy our application onto our Kubernetes cluster. So when we talk about the EKS nodes, so EKS provides us three ways to set up your worker nodes. So we'll be discussing one by one. So when I talk about the first worker nodes which EKS provides us is the self-managed worker nodes. And when we talk about self-managed worker nodes, that clearly means um, I'll just say I'll take this that what we know is that we have the control plane over here, which is managed by AWS. Over here, you have your um, control plane set up in three AZs. Let's take an example. And when we saw that it is backed up by an NLB, which gives me an API endpoint to integrate, to communicate, right? And over here, now I have a VPC which is customer VPC, say our VPC, in which we'll be setting up our worker nodes, right? And we also see when we were creating a EKS cluster, it asks us to provide the VPC and the subnets so that that will host our Kubernetes resources, all the resources like load balancers, your worker nodes, etc. Right. So the first comes is the self-managed worker nodes, which EKS says. Right. See, the original option that was available when EKS was first announced, right back in I think 2017 probably. So running worker nodes was to manually provision EC2 instances or the auto scaling groups and register them as worker nodes to EKS. And this option, if it when we talk about the managed services, right, then what is the point in when we have just dealt with that my control plane would be totally managed by the EKS part, then why is it so I'm dealing with still dealing my own burden, and I will be creating the worker nodes. I'll be managing all the components of the worker nodes that we already discussed, that we have three components. We need to set up a container runtime engine, we need to set up kubelet, kubeproxy as well, right? Then what is the way in this case why we are doing it self-managed? So yeah, this options does not benefit from any managed services provided by AWS, but however it gives us the more flexibility, if I say, in configuring our work nodes, right? So since we are not relying on any of the managed component in this approach, what we can do is we can configure everything, including the AMI, the API access on the node, the registering node, and the registering node to our EKS, and the graceful termination as well. So basically, when we talk about self-managed worker nodes, so we have the whole we can say the whole area of judgment, that whatever you can do with your these worker nodes, you can easily register them, what all different kinds of node you want to register, right? Whichever one you want to take out from your cluster. So that would be totally handled by you in this case. So basically, when we provision EC2 instances as a self-managed worker nodes, what all points or underlying requirements we need to check or we need to set, right? So most of you people might have worked with AWS, and when you start dealing with auto scaling groups, basically, right? So what you do is you create a launch template. In launch template, you provide your AMIs. Then those AMIs could be your fixed with your security patches, the basic components which needed to be required when you are setting up infrastructure for your production level, right? Similarly, in this case as well, we built an AMI which has all the components installed onto that AMI. So we can say your kubelet, your CRI, right? So all these components basically would be set up onto your AMIs. In that AMI, you would be using with your launch template and integrating it with the auto scaling groups, right? Then you associate security groups, right? So when I talk about security groups, basically, as we already discussed, that this communication from master node to control nodes and control nodes to master nodes is a two-way communication, right? And when I say that the outbounds from your worker nodes which needed to communicate with your the API endpoint of your control plane, what it should be, that outbound rule should give the rule of 443, right? For your HTTPS traffic, so that it can integrate with your or it can communicate with your API endpoints, right? And then when we have defined the outbounds of my worker nodes, then what it should be in terms of control plane. So definitely the inbounds, right? The inbounds at 443 in the control plane side, and 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 already discussed that it's a two-way communication. Basically, then what would be the outbound for Kubernetes? Basically, Kubernetes control plane, it would be your 10250, right? Basically, the kubelet port which is running on. So when we talk that whenever the control plane want to schedule the workloads on the worker nodes, it communicates with the kubelet, right? So basically, the outbound rules for the control plane should be your 10250 for your kubelet, so that your API endpoint of the control plane can communicate with the kubelet which is being set up onto your worker nodes. So what we discuss is that the underlying requirements. What first was our AMI, then we discuss about the security groups, and once those are done, we'll be setting it up onto our auto scaling group, and an auto scaling group will start creating those instances, right? Let's take an example. I have set up that I need to set up 5 worker nodes for my production level grade environment, right? Then once my EKS nodes has been created, right? Those worker node instances, right now those are just simple compute engines resources, right? Those are not the worker nodes, because those compute engines are not yet associated with your control plane, EKS control plane. How would you do that when you're dealing with the self-managed worker nodes? So basically, you provide the bootstrap calls. So basically, when you spin up the computer resources, you can provide the details in the user data, right? People generally do then that when they need to do some security fixes or some default setups on their machines, they do write manual bash scripts or these scripts into their user data. Similarly, we give that bootstrap script. Basically, those bootstrap scripts are available open source on the GitHub repositories. So if I even show you, I do have that bootstrap script. Basically, those bootstrap scripts just consist the script part which you can set up onto your AMI. And what does that bootstrap script needs is your API server endpoints requirement when it comes when you want to register your EC2 compute engines as a worker nodes inside your Kubernetes cluster. So these are the details, these are required at this point of time. So basically, the API end server point you are providing, that would be your EKS endpoint, which we saw. Then basically your Kubernetes cluster certificate, right, which we saw over here, the certificate authority, we provide that as well. Which is basically decoded at the base 64 level. So we have provided the certificate as well. So these arguments are passed on while setting up the bootstrap call when the instance is spinned up. And once these details are provided, then Kubernetes cluster the worker node start communicating with the API endpoint, and those certificates get verified from the EKS side, EKS control plane side, and those nodes start getting registered itself under the EKS cluster. So this is how a self-managed worker nodes works in this place. So if I want to summarize, that self-managed worker nodes have the highest infrastructure management, but in returns give you full access to configure the workers nodes to meet almost any of the infrastructure which you need. So if you are willing to exchange some of that control, such as the forgivability of the AMI, you want to upgrade those AMIs, right, for better managed experiences or address spaces concerns like updating, then you can turn to the next option. So this is the basic in which you are getting the full access to configure your worker nodes in the self-managed concept. So this is one of the kind. I hope making sense. I know it's more about a theoretical part, but when we are dealing with the introduction, we do have to get the basic idea that how all different components which EKS provides, the control planes, the different worker nodes planes. Right. So one we have already discussed, that is the self-managed EKS worker nodes, which you can create on your own with the help of auto scaling groups with your default AMIs, which have the all the components here like kubelet, your CRI, right? And after that, once you have created your compute, you need to get it registered with your EKS cluster, and that also we saw that we do have the bootstrap calls which runs at the time of user data when they are provisioning the EC2 instances. And those bootstrap calls, what it requires the API server endpoint and the certificate so that they can start registering themselves under that EKS control plane cluster. And how we can check that, you can, because as you have already set up your kubeconfig onto your machine, what you can kubectl get nodes, and you can give a watch, right? And once those nodes get started registered, you will be seeing that as of now I have already created 2 nodes which has been registered to my EKS cluster. That's why they're showing it. I hope makes sense. Yes or no?
Yeah. It is.
It is. So I'll ask you people, is it going the way you people wanted to? So basically, what we heard in the morning discussion, that people were basically new to EKS, how EKS works, what are different components EKS have. Right. So probably till now you people might be getting the whole concept, that how we have been clean out with all that burden, those operational tasks, and AWS is managing from their side to set up each and everything. Yes or no?
Yes, Deepak.
Yes.
Great. Okay, then moving forward, as we said, then what is the point that when we are talking about managed services and still we are managing the worker nodes on our own, right? So the second which EKS provide from their side are the managed node groups. So basically, managed node groups are designed to automate the provisioning and the lifecycle management of nodes that can be used as EKS workers. This means AWS, now in this case, AWS handles the various concerns about running EKS workers using EC2 instances, such as it could be like running the latest EKS optimized AMI. In the previous case, what we were doing is we were creating our own AMIs, right? In those AMIs, we were setting up each and everything on our own. But when we talk about managed nodes, then in this case, AWS handles each and everything, running the latest EKS optimized AMIs, gracefully draining nodes before termination during a scale down process, we can say, right? Rotates on a timely basis, rotates the nodes to update the underlying AMI, and many more things we have, right? So as of now, what we did is we saw the self-managed one. Now we are talking about the managed node groups, right? So how we can do that? So when we talk about the self-managed one, and when we integrate those self-managed worker nodes with our cluster, we don't get an overview of those nodes over here, right? And when we are dealing with the managed worker nodes, right, we get the details of those worker nodes over here, because when we talk about managed, so basically AWS is managing them, and they have to give an overview of that whole overview of all those machines they have integrated with our EKS cluster. So as of now, over here I can see my new cluster which I created, the EKS demo, has no compute associated with it. Right. What we can do is we can proceed with the managed node group configuration. Basically, when we are using this type of configuration, the add node group, this means these are the managed node groups. These would be the instances, or these would be the worker nodes, which would be managed by the AWS side. We'll be talking furthermore that how at which level they are managed and what all we have to do from our side as well when we are talking in terms of managed one. So I'll say that EKS, I'll say worker node demo, right? Again, in this case, it asks us for our EKS node policy, right? They need a node IAM role. Basically, the purpose they selected to use self-managed node group, as this could lead to service interruption. So basically, EKS node policies, these policies are again required to manage network infra, those network interfaces, right, from AWS side. That's why what we do is we give the EKS node policies to the configure while configuring the node groups. Over here, what we can do is we can directly use the launch templates as well, which we provided, or we do have some of the launch template, the CloudFormation templates available as open source, so we can use them. Or as of now, what we'll do is we will go with the default ones. Over here, we are not using any of the Kubernetes label, taint, intoleration, concept, and tags, because these are the something which are to be deal with the basic Kubernetes component. Okay, it says that we can. Okay. Now, what it's asking for is set compute and scaling configurations, right? So over here, I'm setting up that AMI type which needed to be used, which need to be used. So Amazon Linux machine capacity type on demand. I'm using a T3 medium type of instances. Disk size to be allotted to that. Each compute should be of 20 GB. Now this what is asking is about the node group scaling configuration, basically the auto scaling concept. So what minimum, maximum, and the desired thing you have to put in from your side. And when we talk about minimum, maximum, and desired, so basically this concept is when the current workload is being set up, so minimally 2 worker nodes would be running from my side, right? And if I set it to the maximum size 5, so when my workload increases, my worker node size would be increasing, right? And once my worker node size increases, it is start increasing the desired size as well, because as we discussed, the desired size is versed with the actual state, right? So basically what it does is let's take we have the minimum parameter which we defined is for 2 worker nodes. Right, moving forward, what we said is that maximum it should be 5, right? 5 worker nodes it should have. Sorry. Okay. Okay. So I'm setting my maximum desired condition for if my workloads increases to the 5 number of worker nodes. So desired is something which runs with your actual state, which we already discussed, right? So the desired, as of now, presently 2 worker nodes would be running onto your system. Then the desired state for your cluster would be your 2 worker nodes, right? Once the workloads start increasing, let's take an example, workloads start increasing, and now 3 nodes would be required to surpass that workload, right? To serve that workload. Then the desired state would change to 3, because currently the actual state of your cluster is 3 worker nodes. Then if again traffic start increasing, my worker nodes needed to be increased, then it's switched to 4 worker nodes, and the desired state becomes to 4. I hope this makes sense. So the desired state actually maps the actual state of the cluster. It's equals to the actual state of the cluster. So that is your desired state. So over here we have minimize 2 worker nodes. I'll keep the same as of now. Node group configuration. So and maximum available. So basically, the rolling updates when it happens. So basically, the AMI is needed to be updated onto your clusters. So what all parameters or what minimum configuration should it keep while running your EKS cluster is that number value we are providing over here, that one node should always be up while even updating the base infrastructure. And again, the same node group network configuration, we are providing the subnets in which all those worker nodes would be hosted the way we did in creating the cluster as well. And after creating next, we have a review and create option, and finally we create it. So as discussed, that these compute engines are just these worker nodes are just basically like your EC2 engines. So you can even SSH onto your worker nodes, right? So somehow we forgot to enable this SSH access. When we enable the SSH access, it asks for the PIM key which you want to keep accessing for your worker nodes. So these are the basic compute engines which we use to create when we are dealing with the AWS services. So basically, you can SSH to these worker nodes. You can improvise. You can change. You can make changes whatever you require. So that is something which you can do from your side. So, but as of now, what we have done is we have created a managed node. It will take some time and it will start reflecting onto a node page, that one managed node group you have created, and those has been associated with your EKS cluster. And when we say that, in this case, how they are starting getting to registered, so they are automatically, because these are the managed node groups. So AWS will be handling it from side, that how do I need to integrate this with my EKS cluster, these worker nodes with my EKS cluster. So AWS is handling this thing. But one thing to note is that while managed node groups provide a managed experiences for provisioning and life cycle of EC2 instances, they do have some limitations as well. So they basically have do not configure the horizontal auto scaling, the vertical auto scaling. This means you need to use a service like the Kubernetes cluster auto scaler, implement auto scaling underlying ASG, right? Additionally, as well, managed node group also they do not automatically update the underlying AMI, right? Basically, when they say we do so, but I'll show you that in my test EKS demo. Workloads. So whenever I do have the upgrades for my AMIs, I do those things manually. I click on the instances, I go to that raw view. Those updates configurations are being provided to me over here. Just like you can see that when we are dealing with the test EKS, it's showing me the update here, right? New versions are available for one add-on, or a new Kubernetes version is available for the cluster you can update. So it's still being managed by AWS, but you have to give a manual intervention to them as well. So that, since it doesn't make sense, right? Still these are being managed by AWS, and my production level grade was serving the traffic, and suddenly somehow what AWS think is it's the time to switch to the newer version, and they'll start upgrading the cluster version. And what I see is that my application is breaking down in the production level. So basically what it says is we'll be managing each and everything, but you have to give a manual intervention as well, that when you want to update or when you want to not, right? They give continuously notifications as well, that it's the time that you should update, or it would be deprecated, or the plugins support which you are using right now might be with the previous version, it might not be supported, so you should update. So they give you the specific times, they start notifying you that you should update upgrade your cluster now to the newer version. And it's our responsibility that when we want to proceed with this functionality at the off hours of our traffic, or whatever you select from your side. Right. So to summarize, managed node groups are a good solution for having a managed experience for managing your worker nodes without giving up too many Kubernetes features. But however, you still have worker nodes to manage yourself. This means that you still have to worry about the concerns like SSH access that we just said. The SSH access, we can enable the SSH access. The auto scaling group, the auto scaling means it's not provide from their side. What we used to do is the generic Kubernetes core components of cluster auto scaler, right, and updating patches. So what if you, now the third option which we see in EKS side is the AWS Fargate option, and AWS Fargate option is something uh, which is serverless worker nodes, right? So when we want to see that completely get rid of overhead of managing servers, then the third option, the final options, gives us exactly the same. That is the Fargate. So basically, I'll not go into a deep dive into that one. Basically, I'll give you just a gist of that. That AWS Fargate is a serverless compute engine managed by AWS to run container workloads without actively managing servers to run them. Right. What all you need to do is to tell AWS that what all containers you want to run. AWS will then figure out how to run them, including under the hood automatically spinning those servers cluster up or down as necessary as well. So this means that you can schedule your workloads without actively maintaining or managing those servers to use our worker nodes. Right. So this is what AWS Fargate or serverless worker nodes provides you the feature. I hope till this point of time this makes sense and you people are getting it. That what all different features, what all different functionalities does EKS provides us. Yes or no?
Yeah, makes sense.
Pretty good. Okay. So then finally the point comes is we are done. We are done with our um, EKS cluster setup. We are done with our control planes. We are done with our worker node setup. We have integrated our worker nodes with our EKS cluster. They are able to communicate. Now what we can do is we can start awarding the kubectl commands and start deploying our workloads or heavy lifting to our worker nodes, right? Then how EKS networking for EKS nodes works, that's the point which needed to be discussed and which should be discussed, right? And when we say over here we are talking about the worker nodes, right? So let's take an example that I have my VPC, right? Because the are worker nodes are hosted in your VPC, right? The customer managed VPC. So I have my VPC over here, let's say, and then this is my subnet, I can say. Uh, right, which has a range of side range of 10.0.0.0/24, basically, which roughly gives me about 254 IPs. So basically, this is something generic in terms of AWS perspective, right? Of the basic networking concept, not even the AWS perspective. Now, what I have is worker nodes being set up, and when we talk about the networking in the EKS nodes, right? So AWS comes with the AWS VPC CNI plugin, which helps you to communicate your nodes, to help you out to communicate between your pods, to between your nodes, communication, right? AWS VPC CNI plugin is in the place in that place. So basically, let's say even I have a worker node, and those worker nodes would be getting an ENI attached. Yeah, right. Your NIC card being attached to your worker nodes. Basically, this is how my all my compute engine works. Right. I have an ENI network NIC card attached to it, and let's say that this node in this worker node has got the IP of 10.0.0.1, and this got the 02. Right. So and in when we are dealing with the EKS clusters or the Kubernetes in terms respective to cloud platforms, we choose the instance category type, right? even we have to make the judgment for the cider range as well, because when we are dealing with the at the production level, you need to select the cider range such as that your load requirement could be fulfilled. That if you are running multiple pods, thousands of pods, then probably this cider range won't work for you, right? You need a higher profile of cider range. Take an example that slash 18 slash 16 or something, right? Slash 20, so that you can get a higher range of IPs which can be allotted to your machines. Okay, there's something when we deal with the worker nodes. So we just saw that as well, that while creating a node group, it asks for the AMI template and the the instance category type, right? The so we gave over there T2 medium. Does is we have the NIC intercard limits as well. So what's the purpose behind this is that when we talk about these interfaces, how many interfaces can connect, right? So over here we have all those things. So let's take an example that I have an instance machine which have C5 2x large for my worker node setup. So this is my machine which have C5 2x large worker node setup onto my machines, right? And what it says is that C5x large can have maximum of 4 network interfaces. Those are 4, and private IPv4 addresses per interface could be 15, right? So basically, when I talk about, I can in total I can have 60 IPs for this instance or for this machines, right? So when I have this machine onto as my worker node, this worker node can have 60 IPs associated with it. And now in this case, the Amazon VPC CNI plugins comes into the picture. Basically, what it does is, so I say that C5 to XLART said that 2 network interfaces can be attached to it. So one has been attached, right? So one IP has been consumed and 59 IPs has been left. So what CNI plugin do is, CNI plugins grabs all those remaining 59 IPs and keep it with them directly from your VPC. The VPC CNI plugin. Basically, what changes you see here is when we deal with the basic Kubernetes networking. So your node instances IPs were different and your containers pod IPs were different because they were following the Linux network namespace networking concept, right? You were setting up your node instance. Your node instance might be getting us IP of let's say 172 dot something, and when you are seeing your container pod IPs, you might be seeing those are associated with like 10.0 something, because they were following a virtual network interface which been connected to your containers interfaces, right? And for that you need to set up any of the third party tool like Calico or something, which was translating that with the help of NAT to your node IPs, and then you was able to communicate with your pods between different worker nodes. Basically a setup of overlay networks when you deal with the basic configuration in Kubernetes. But when we are dealing with the EKS, what EKS did was that EKS tries to make it a lot easy at the expense of making you know more about VPC networking. So basically what it does is, so it introduces a VPC CNI plugin, and what these plugins do is, these plugins on the type of the category of the instance type which you are using. Over here we can see the C5 2x lot, which has the 60 IPs allotment possible, in which one is already allotted to the worker node. After that 59 left. What it will do is, it will grab all those 59 IPs and kept it at their level. And once the pod is deployed onto this worker node from the IPs which has been grabbed from your VPC cider range or the subnet cider range, it will allot another IP to your pod IP. So basically how does it help is that if we are designed up in a single VPC onto a subnet, we have a VPC router. This is basically the AWS networking concept, right? So VPC networking concept. what it does is, if my pod is need to communicate with the different pod which has been hosted onto my different worker nodes. For example, let's say 10.0.17 it has, right? So what it'll do is it'll directly go to the VPC router, the router which has been associated with my this VPC, and it will be knowing, because the IPs which are being assigned to the pods are from the CIDR range of the subnet provided. So right, this network would be knowing that these IPs, or the IP which it needs to communicate with 10.0.017, belongs to my CIDR range. I know about it. I can directly hop in and communicate this traffic to the pod which it's needed. So that's the basic benefit which VPC CNI plugin is providing to you. So AWS CNI plugin is responsible for allocating the VPC's IPs to the Kubernetes node on which the pod runs, and configuring the necessary networking on each node. If I talk about the basic in depth as well of the VPC CNI plugin, then we have different components as well. The LIPAM daemon, which is responsible for attaching elastic network interfaces to instances and assigning secondary IPs to these ENIs. So basically, secondary IPs is something, if you can see in the Amazon EC2 instances, I've already hosted um, two worker nodes, right, as shown. So basically you are seeing that private IPs, these are the T3 micro. So IPs for the instances are of 173.31.0. These IPs has been get from the range of subnet CIDR, if I'll show you. So okay, here you can see that my subnet CIDR range was 172.31.0/20, and you can see that the subnet, the instances which have the worker nodes which got the IP from the subnet range, that is a basic EC2 configuration which we see. And how does VPC CNI plugin help me in allocating the same IPs to the pods itself from the CIDR range of the subnet? So we can check it over here. If we see kubectl get pods -o wide, you can see that even the pod IPs are allotted from your subnet CIDR range. So this makes this easy. This AWS VPC CNI plugins makes easy in the networking concepts of EKS, that you don't have to create or set up the overlays network which has been already been not been followed as now, because we have the multiple cloud platforms solving these issues, be it about AKS, AWS VPC CNI, similarly goes for AKS as well. So what it does is what they do is they directly grab the IPs, keep it with them, and then they associate the IP addresses, the IPs to your pods, which has been provided from the subnet CIDR range. What you can also do is you can even change the settings of the VPC CNI. Instead of caching all those IPs instantly directly at one time, what it can do is directly when the pod is allocated onto this worker nodes, it will directly go to the CIDR range, the subnet CIDR range, and then will allocate the IP addresses. But if I talk about at a higher production level grade, when we are dealing with thousands of pod, then it won't be a greater approach to do so, because in a regular interval of time, there are multiple pods who are at regular interval, they are pinging the CIDR range, they would be pinging the CIDR range to allocate the IP addresses to their pods, and that could brings the issue of the latency as well. So the better approach is to keep the VPC CNI plugin, which is gripping the IPs for the instances, and then the IPs could be allocated to the pod itself. Right. I hope makes sense.
Very good morning, ma'am.
Yes.
Okay. Great. Great. So this was the basic networking concept which we saw for the networking part in the EKS nodes. How does it allocate the IP addresses to the pods and everything, and how they communicate, because they are well known with throughout the VPC that this is the IP which has been associated to the pod from my subnet side of range, and they can easily communicate with the different pods onto a different worker nodes because they are known to this traffic, because they are known to this router service. Great. Moving forward, as we already see that networking EKS working, we have already seen we have provisioned the clusters, we have deployed the worker nodes and connect those worker nodes and start deploying our application as well. So I did deploy a basic, if I say I'll go to this CD Nginx. I basically deploy a basic deployment of Nginx with the replicas of 2, and it deployed my pods as well. So we can start deploying our workloads onto our worker nodes, right? We've discussed about EKS networking as well, that how EKS node networking nodes concept, and similar diagram I have given over here as well. It has created the ENI attached to your node once, right? The VPC side range is this, subnet side range is this. It will be allocating with the help of CNI. It will be grabbing those IPs, right, and associating it with to the pods as well, similar to, and which are associated as a secondary IPs to your node instances, which we can see over here as well. In the networking part, if I go, you can see that 172. These are the private IPs and the secondary IP, the secondary private IP addresses. So if I CV 241 183, so these are the pod IPs which are associated. So once we start creating or deploying more pods, the maximum range of the instance category, that how many IPs it can grab up to, and it can allocate how many ENIs can be interfaced with those category of EC2 instances, is directly being followed from the AWS document, the official, right? So it's our responsibility to that what type of category instances we node as per our workloads requirement, right? So if we need a larger number of pods onto our worker node, definitely we'll be choosing a bigger instance type so that maximum number of interfaces can be attached, maximum IPs batch I can be allotted, and I can associate with it with my pods, right? So this is all about the basics of EKS cluster part and the setting up of clusters, starting from the containerization. We discuss about the orchestration fundamentals, then why EKS, what EKS, different components, the core components of EKS with their architecture, be it about control plane, be it about our worker nodes, right? And then we proceed with the networking concepts as well, that how AWS VPC CNI plugin is helping out and associating the IP addresses to our pods. I hope till now it makes sense. Hey. Yeah. Great, great. And finally, what we have is we have the best practices for EKS, right? So when we are setting up, it's totally a deep dive as well. We can do a deep dive as well in the best practices part. I'll just start with the basic, the IAM part, right? So when we are dealing at a production grade level and the organization level, definitely we have multiple users. We have developers, we have database users, we have DevOps admin, super admin, right? And we want to create their users as well onto our cloud platforms, and we give the least, we follow the principle, the best principles, the least minimal access which you can give to your cluster endpoints, right? So in that case, IAM comes into the picture, right? Um, and again, over here as well, the points come as the authentication and authorization, right? But when we say authentication and authorization, does AWS IAM is helping to do both the authentication and authorization part for the Kubernetes cluster? So no, that's a big no. Authentication is something which would be dealt by IAM, and when we talk about authorization, the authorization part is which is dealt by the Kubernetes core component, that is RBAC. If I talk about RBAC, basically RBAC is something. I'll just show you. Over here we do have two types of RBAC in Kubernetes, right? We have the role RBAC, the role policies, and the cluster role as well. Basically, roles are being set up at the namespace level and cluster in setting you are at the whole level, right? So over here, basically, you can see just that I'm setting up an RBAC cluster role binding, right? So these are the basic Kubernetes manifest file of kind cluster role, in which it's saying that API version RBAC authorization, cluster role metadata. I'm setting a name, monitoring endpoints. I'm giving the labels, right? And what all rules I'm giving it to it. So API groups could be anything. Resources, in resources, I'm saying that for the services, for the endpoints, for the pods, here it could be anything as well. We can set deployments, the service, the config maps, the secrets, what all resources, different kind of resources Kubernetes support, we can provide in the form of list. And verbs is the main actions which we provide, right? That it has the access of get or list or watch. So basically we have the different verbs: get, list, watch, create, right? And after that, update, patch, delete, each and everything. After once we have created a cluster role, so I'll just give over here. So I have I will show you that this is my K8 cluster, right? Okay, just leave this. I have a K8 cluster, basically the control planes, right? And when I talk about the K8 cluster, what we deal is directly with the API endpoint of that cluster, right? This was my K8 admin machine, in which where I have set up the kubectl, right? And which would helping me out to interact with this, right? So let's take an example that what I did is I created three different users. I created users like super admin. I created admin. I created a developer. IAM users, right? And basically, when you assign policies to them, so basically from over here, when we are dealing with the IAM roles, what they do get is I'll show you. Okay, I'm just saying that I'll create a role. I go to the EKS. Sorry. The role which I need to select the policies which I need to associate with the users, right? With a role or something. With the instance role which I can associate directly with the users. Choose a service. Right. So over here, what you can see is we get the four permissions, the four access level. We have the list one, we have the read one, we have the tagging, and we have the write one. Right. So over here, what we have is, so if I talk about a basic super admin user, then with these access, what you will be all be giving is you will be giving him all the accesses, right? To list one, to read ones, to tag, and to write ones. So basically, list, read, tagging would be something that when coming to this AWS EKS console, he can list out that what all clusters are being in this system, right? The different things. And then we give when we give the write options, then it has the options to even to delete these clusters from here. An example that I have given all the permissions to the super user, right? And then I have given list and read and tagging options to my admin user, and then only the list and read options to my developer user, which we already discussed, right? The way which discuss the super admin, admin and developer. The super admin has all the users, then it has the list, write once, the list and the tags once, and it just have to list and read, right? But these all permissions are something which is related to your AWS console, right? Not more than that. But what about the internal resources which we deal with Kubernetes, right? Your pods, your deployments, right? Your service, your config map. How do we deal with that? How do we deal with that level of authorization? So in that case, your RBACs comes into the picture. right? So let's take an example. I created an RBAC for an API resources like for service, endpoints, pods, each and everything. Then what I have to do is I have to do a cluster role binding so that can come into an effect of for my cluster. Just give me a minute. Okay. So over here we can see that once we have defined the cluster role, what we do is we define the cluster role binding as well for that cluster role. Over here you can see the kind cluster role binding. You have defined the metadata, right? Over here you define your kind. So as we have created a users, so what we'll do is we'll use a kind of user, and then we can give the name. So over here we can give the super admin user, the admin or the developer one, and as per their responsibilities we'll be defining all those verbs and resources which they have limited access to. And once we have applied these cluster role bindings to our Kubernetes cluster, apply those rollback RBAC YAMLs. Now authorization has been over here. It has been set and it been updated to our cluster. Now, how can you check that is all those limited resources are working on my Kubernetes cluster or not? What you do is basically when you are deal with any of the AWS CLI services, you set up your access keys, right? AWS configuration keys, right? So for different IAM users, they have different accounts. They have their different secret and access keys, secret keys and access keys. So similarly, the way right now I am using this AWS get caller identity. Similarly, when we used to AWS configure for all those three different users, we can check that at right now at which point I'm which user. Am I a super admin user or a admin user or a root user? So we can do that. We can set this context, and for that we use the basic AWS util command, which set the kubeconfig context to our kubeconfig file. For just like that. Over here, as it is a user, root user, it is not showing me that. But if it was an IAM user, then it would be have the parameters like AWS IAM authenticator and the username as well. Then that this user context has been set up for the kube cluster. So let's take that kube cluster map role was set up for the developer, and in while dealing with the RBAC authorization, what we did was we just gave the permission to list or read the processes, right? Then what it could have done is only the developer user can only get pods or describe pods, just these permissions. It can't create or apply those pods or can't delete these pods. So that's how IAM authorization works with the RBAC authorization. The IAM authentication works with the RBAC authorization. If I talk a basic overview, then what it does is that over here, if I have my client or me as a user, it passes on the AWS identity to the Kube API, right? And after that, what it does is basically I'm passing the kubectl command, right? And then what it does is it's verify with AWS and then it authenticates your identity with AWS IAM, that are you feasible to enter in this cluster premises or not, right? After that, when it has succeeded, it gives back response to your kube API. And finally, when you are using that, you want to list the resources, or you want to create those resources, or you want to delete those resources, those manifest files, then what it does is the kube API confirms it from your RBAC resources which you have applied onto your Kubernetes cluster. And once the resources which has been allowed or which has been given permission to that specific user gives back the response to the Kubernetes API, and then you see the Kubernetes action in front of you on your terminal. Is it allowing you or is it denying you? So this is the basic concept that how your authentication and authorization works. I hope makes sense. Yes or no? Yeah. Yeah. So moving forward, that was the IAM network security. If we talk about, then basically the security groups you can say in terms of AWS VPC networking, your inbound, your outbound rules that we already also discussed. That you can outbound to the 443 to the specific APIs endpoints of the Kubernetes cluster. When we are talking about the inbound as well, the outbound as well, we can limit those resources restrictions to the CIDR range in which we are hosting our Kubernetes cluster. Similarly, for infrastructure security, we can host our worker nodes, our whole total EKS cluster onto a private subnet instead of deploying onto a public subnet. And also, while dealing with the EKS cluster, we can do is we can instead of giving a public endpoint access, we should proceed with the private endpoint, and that's the best practice while dealing with the production grade level. Image security is something when you are integrating an ECR AWS service with your EKS cluster, right? You are creating your images, your application images, and you are hosting or you're registering them or you're pushing them to your private ECR repository, right? And when we talk about data encryption and secret management, so you already see that when we talk about we are setting up a control plane onto a Kubernetes cluster, we have control plane onto EKS, then the HCDs uses the EBS volumes, which are already encrypted with the help of AWS KMS. And as well, you see that while creating a cluster, it was asking the option of are you want to do you want to enable the secret encryption as well with the help of AWS KMS. So many functionalities EKS provides, and that doesn't end over here. We do have multiple best practices. We can log out, we can check out on the official documents as well, be it about EKS security groups. Even we saw the Kubernetes cluster logging, which was giving us that you can enable the API logging, the audit logging, the scheduler logging. Those are some kind of best practices, less public accessible cluster endpoints. So these are multiple best practices which can be followed while dealing with the best practices for EKS. So yeah, that's a pretty great which we discuss about the EKS starting from containerization to the orchestration fundamentals to the Kubernetes, then how AWS is providing us a managed service known as EKS. We check out setting up control planes, we check out setting up managed nodes, right? And when we talk about the worker nodes, we have the concepts of three different kind of managed worker nodes. We have self-managed, we have serverless as well in terms of AWS Fargate, right? Moving forward, we saw the networking concepts of node, how AWS VPC CNI plugin is helping us out to associate the IPs from your subnet side range to your pods, right? And finally, we even saw the identity access management, the authorization, the authentication, and the authorization between your client and your Kubernetes resources. And moving forward, many more best practices which in EKS which can be followed. So yeah, that's a wrap from our side, from my side. I'll ask Tanya to introduce the labs which we have created for you people and which you can follow while working with them at your end side.
Thank you, Deepak. Okay, thank you everyone for being an amazing audience till now. If you have any questions, you can ask right now. We will be happy to answer all those queries of yours. Otherwise, we can jump on to the labs. Is there any question from anyone? Okay, I'll take the silence as a no. So we'll continue with the labs then. Over here, I'll share the link in a while, or Deepak, you can share in the chat box. So if you could open the first introduction to EKS. Yeah, so this is a basic introduction that we have just written for your sake. Like if you're doing this lab sometime later, so there is one description of EKS that you might consider to read, and which will give you a very basic idea about what EKS is exactly. Then coming on to our second lab, which is setting up our EKS cluster using the AWS console, which Deepak has already shown you by in his demo. So over here, when you will see, you will get all the prerequisites that you require for this lab, and also we have written step by step what you need to perform during this lab. And if you have any questions, any doubts, we are always available on LinkedIn, and also we'll be adding you on our Slack channel. So all the steps are there, whatever you need. These steps, mind you, are for a very basic cluster that you need, but for an advanced one we would love to hear your response, and if you need any advanced workshops we will be available later. And okay, if you have any doubts in this second workshop, you can let us know right now, because this Deepak has already shown you. um, any questions or anything?
No, Tanya, nothing.
Okay, great. Thank you so much. So third lab that we have written is, so since we have only shown in a demo as a EKS cluster using AWS console, so we wanted you to give, we wanted you to enhance your knowledge in more ways in which we can set up our EKS cluster. So we have added two more ways using which we can set up in the third and the fourth lab. This third lab we are using EKS ETL to configure our EKS cluster. So over here also we have mentioned all the prerequisites and all the steps that you need to perform, and it is very basic. It is a very step by step that you need to perform, and when you will perform all these steps, it will be very easily, your EKS cluster will be available on your console when you will check after performing these steps. And it is not it will not take more than 30 minutes or even less to set up your EKS cluster using this EKS ETL, which in return, when you will do it from scratch, it will take a lot more time, which you might have done already. So now a more easier way that we have done is using a Terraform. I have added the GitLab repository link over here, where we have written all the manifest files for Terraform in this one only, and you can just clone this repo, and over there all of, yeah, you can open the Terraform folder, Deepak. So as you see, all the files that you need are over here. You can read those files. If you have any doubts, do let us know anytime. Okay. So for Terraform also, you just need 2 or 3 steps maximum, which will not take much more time. Only the execution time is there, but your input is very less in this. So in using this also, you will set up in less than 15 minutes. And I hope you do enjoy these labs, and do let us know what your feedback is on those labs. And if you have any questions, I'm repeating again, do let us know. We will be happy to help you guys at any time. Also, I have shared the feedback link with you guys on the chat, so it would be highly appreciated if you do give us your feedback. So, yeah, Deepak, you can continue.
So basically, these three labs are giving you a whole three different perspective of setting up a EKS cluster, right? Starting from a AWS management console to the EKS ETL, and finally with the Terraform modules. Terraform modules, as we all know, are the basic setup or the basic infrastructure provisioning requirement as of now time, right? We do create the roles, different modules, and directly we can call those modules at different perspective. What we just needed to provide is the variable values which has been set up onto our modules, right? So we do have given the examples as well, that how can you set up with the help of Terraform. You just need to provide your specification, what you all require, your subnet ranges, your CIDR ranges, right? Even it has the concept of introducing the spot node group as well, spot instances in your worker nodes. So yeah, give it a try, give it this module a try, and definitely share your experiences, that what all you problem it might be. You might be people who are new to the Terraform, might face some problems, and what all files these are, right? Once you get an idea of the Terraform, definitely you'll enjoy creating your EKS cluster with the help of this module, and it will show you that how instantly, just providing the details, the variable details, you are able to create a cluster in minutes. And apart from this, yeah, now what we can do is we can like to have the experiences which you have in today's workshop, and share your experiences one by one. We can discuss with you, or you can how do you like the lab, how do you like the session, and what all you are expecting in the next lab, in the next workshops for EKS, so that we can prepare as per that. I know this workshop, this today's workshop was more about the introduction to the EKS part. Probably in the coming future, we'll be hosting the sessions which would be dealing with the deployments onto the clusters, right? More into the networking part, right? More into the load balancers concept, right? So probably in the future coming sessions, we'll be dealing or we'll be discussing about each and every component of EKS as well. So yeah. So one by one, we can discuss with you people. Ankit, any one of you can say that what you got from this today's workshop, and how did you feel?
Yeah, please do share your comments or your any feedback for us. So we would really appreciate to include all those feedbacks and comments in our next workshop.
Anyone?
Yeah,
Ankit, Hina, Prabha.
can you hear me?
Yeah, yes, Shiva.
Yeah, yeah. I think the workshop was very interesting, knowledgeable actually. At least I got so much of information and insights about the EKS introduction part, and yeah, even the workshops also the three or four types of whatever exercises you are providing. I think they're very good. I just got the gist of it. Definitely, I'll spend time on the workshop. Totally, it was a very good workshop. Thank you.
Mm-hmm. Thank you, Shiva. What about others? And please do spare time for filling up the feedback form because it helps us out as a trainer that what all points we can accommodate in our next trainings, in our next webinars, so that you people as an audience can enjoy and can interact more, right? With be it about the lab sessions or be it about the theoretical part as well, each and everything. I have again pasted the link on the chat box itself. We will also be pasting onto the LinkedIn event which we created for this workshop, and people who might have missed over here can fill over there. So yeah, what I'll do is I'll also share the Slack link. What you people can do is you can join our OpsTree Slack channel. The channel name would be once you get this link, you will be joining into our Slack, the OpsTree Slack workspace, and after that you can search the channel name as this, the OpsTree external. And once you are in this channel, you can update any related queries to DevOps practices, not only specific to EKS, not only specific to Kubernetes. It could be anything which is underlying being followed under DevOps practices, and we as an organization would be happy to help you out with your related queries. So this is the link which I have provided. People can join the channel.
Also, everyone, I
Okay.
would really
Anyone?
appreciate. Yeah, sorry. Okay, I would really appreciate if you could put your comments, valuable comments, on our LinkedIn post, and you could, share any information that you need on that LinkedIn post as well. Also, along with that, I would like to introduce our DevOps clan group, which OpsTree has created on LinkedIn. I have already shared the link on the chat. I would share it again with you guys on this chat only. You can join this link, and over there we, the entire OpsTree solution, share their any facts about anything that they find, new information they share on that group. And also we share all our upcoming workshops, whatever workshops we are going to introduce in the later future, we share all the information over there. And all the blogs that are written by our OpsTree employees, that is also shared, which will be a valuable read for you guys, so that you can enhance your knowledge more and more over there. So if you could check out that group, I hope you like that group and you would appreciate your our you know so yeah, thank you.